Okay, so we start today, date is 29th. So initially I was thinking of starting GPT-2 today, but we don't have that much time and we'll do it in the next week onwards. So what I'll do is I'll talk a bit more about BERT Tokenizer. So first of all, if we keep our vocabulary the same, I mean not vocabulary, but if we keep our corpus the same, okay. Remember, how did we do in BPE? What did we do in BPE? This is my corpus. What are these numbers? These are the frequencies of these words in my corpus. So I will list all the unique words in my corpus and I will also list their frequencies. Finally, what will I do? I will put them character wise. Okay. Once I am done with this, I will do this byte pair merging. Okay. And how many times do you merge? So let's say if your initial vocabulary is 128 and if you want 30,000 vocabulary, so keep merging until this vocabulary size becomes 30,000. So that was easy. Now what BERT does is, assuming that this is our assuming that BERT, so if we now apply the BERT tokenizer on the same thing, what BERT will do is, so I'll just do it for one, for face, so or maybe for learn. So what BERT will do here is, it will tokenize it like L hash hash E hash hash A and the reason I have actually thought of using doing a lecture on this again, because this confuses people a lot. What is this hash hash? Okay, and BERT is something that is still industry relevant. You will still be using BERT. All generative AI is well and good, but not all can afford to pay for APIs of OpenAI. Okay, so and if you are knowledgeable, you can do 80% of the things using not if not 80%, at least more than 50% of the things using BERT. Then why use a paid API? So this is how you initially split in BERT. This is your first letter, first character. Every character after that will have a hash hash before you write it. Okay. So what is my initial vocabulary? You do that same thing. What was our initial vocabulary for BPE? All these characters, all these unique characters. Same here, but all these unique, these things. Okay. L is different from hash hash L. So that way you might see some, so L is fine. So face is here, right. So this face will give you F, what else? Hash hash A, hash hash C, hash hash E, but this is going to give you H, hash hash of all these. So here you will get hash hash F and here you will get just F, and these two are different. Okay. Make sense? I mean easy. Okay. So this is what it is. Now once you make, you take a basically aggregate of so once you take all these unique tokens in your tokenizer, you start exactly the same process. You want to merge. The only difference with byte pair encoding is what? So you have your measure different. So instead of computing, these things that we were computing, whatever what was these guys, by the way? These frequencies of these byte pairs, right? So in Wordpiece, okay, so what you essentially do is this, you compute. So if you want to compute, h hash u, right? If these are the two byte pairs you are talking about, then so the score will be given by frequency of the pair divided by frequency of first, let me call this in general F1, or maybe F1, F2. So frequency F1 dot frequency F2. This is what it is. Yes. Matlab, dekho, what we are saying here is frequency of the pair. So for example, things like ing, right? Ing, if you see, I will appear at a lot of places, but ing together there is a substantial amount of text in my corpus where I will see this continuous ing. So what does this score capture actually? You have h, you have u. What does it mean if this score is high? See, if the frequency is high, what does it mean? It means frequency of F1 dot frequency of F2, frequency of the pair, if this number is high, this will basically mean that, for example, h and hash u, they appear together much more compared to what they appear individually. See, if this number is high means denominator is low, and so this basically means individually h or hash u, they don't occur as much, but whenever they occur, right, usually they occur together. So if usually 2 bytes, 2 tokens occur together, what should I rather do? Make a token of them, because they usually occur together. So all these things you rewrite them, using our this hash notation now, and compute the scores for everyone. Whichever gives you the highest score, merge that, and keep on doing this until you reach the vocabulary size. So if you have kept 30,000, then 30,000. If you have kept, by the way, I was looking at one of our BERT lectures yesterday, and remember one of you had talked about that the number of parameters in BERT and GPT were different, and it was stupid me. So why the number of parameters will be different even though everything is the same? Because everything is not the same. They have vocabulary sizes different. One has 40,000, one has 30,000. So you keep the rest of the architecture same, but you will still have differences in the number of parameters, right? So GPT had how much? 117, I think, and BERT we talked about 110. So 768 cross 10,000 will give you roughly 7 million. So that is where the difference is coming from. Okay. So I think we are done with this. So this is okay. Last time you were ordering based on this frequency scores. Now you are not frequency scores, these frequencies, right? This time you are ordering based on these scores, and you keep on merging them. Okay. Rest of the process is same, just that there you were using some other numbers to compute ordering. Here you are using this score to order. That's it. Questions now? Okay, sure. So now there is one person's tutorials so this person, right, Chris McCormick, I mean I recommend very highly. Right. So you can go and have a look at this playlist, even though we have covered everything, but I still recommend you go and have a look at it. But what I am more interested in doing today is, so I'll open this collab notebook and this file. So this is vocabulary of BERT, okay, and we'll just go through it. That's it. Collab I have opened because that will help us navigating through this. So and you will see any code that involves BERT should be super easy for you now. So when somebody says import BERT Tokenizer, now you know what exactly are you importing and what will it do. So he is generating this vocabulary.txt through this collab file. Now, so from pursuing the vocabulary, I am seeing that, should I increase the font size at the back? Fine. Okay. So first token is pad. So first 999 tokens appear to be reserved, and most of them are of this form. Okay. Now, one is pad, 101 is UNK. What is UNK? Why do still need unknown? So, can anybody search how many Unicode characters are there? Total Unicode characters, how many of them are there? How much? Sure? So, that's a big number. right? And BERT vocabulary is, I doubt. Oh, okay. So that's a huge number. That essentially means BERT cannot have all Unicode characters, right? So BERT might still see something which it does not have in its vocabulary. So you have unknown here. How is it different from unknown of word based unknowns? See, when we were having vocabulary as number of distinct words in my corpus, if you have unknown there, how is it that different from this one? It is for a character. That means for most of the things like English, we'll see vocabulary and then maybe come back to this discussion. 102 is CLS. So it's a special token in BERT. What was CLS, by the way? That leftmost thing, right? SEP, separator. And then this mask. This mask was used for mask language modeling. Okay. Now 1000 to 1996 appear to be a dump of individual characters. Okay. So let us go here. We have talked about this. Now these are, so UNK, CLS, SEP, right? Okay, so now you see individual characters start. Okay, so you have individual characters starting from 1000 to roughly 2000, 1000 to 1996. So all these individual characters. And you will see there are numbers here from, digits from 0 to 9, all these things that you will find on keyboard. You have English letters. So these things are expected because they are there on the keyboard itself. And you can find many more. So you will also find, letters of Hindi here, Bengali. So BERT is huge. Now I'm just looking for any of the, so this is I think Arabic. Now see Hindi. Okay, I don't know why don't they have this EE, or maybe I just couldn't see it. Okay, so A, U, A. So later on they do have these matras. Okay, so they have these things. Okay, now this, if I am not wrong, is Bengali. Anybody? Yes. Now this is, I don't know, but still Indian languages, right? Looks like Odia to me, but could be one of the South Indian languages too. I don't understand them. Now, so what I want to say here is BERT vocabulary is huge. Now earlier you were having vocabulary of size 200k, 100k and only accommodating English words. Now you have a vocabulary of size 30,522 and you can accommodate so much, right? So many languages. So that gives BERT its power. In 5 years, roughly 1 lakh citation. That's a big deal. So I'll just so Chris here mentions they don't appear to be sorted by frequency. So these are just dumped there, not sorted as such. Now the first word is there at position 1997. This was the problem with this. And now I think I have lost track of where I am. But not too far. Okay. So this appears to be Mandarin, right? So Now the, of, and, in, to, was, what does this suggest? This appears to be in the order of frequency of appearance in English text, right? Because the appears the most, then the of, and so on. So this appears to be in the order. Now what is this the and what is this hash hash s? The is normal the word, okay. So BERT in its vocabulary has word the. It is not, it is not breaking the into parts. The occurs so much that it wants the word the itself. Similarly for of and so on. What is hash hash s? This is a subword, and so why frequency is so high if this is sorted by frequency? Exactly, right. So when you make plural houses, rooms, so you will have this word and then followed by s. So hash hash s has a really high frequency. So I think we have started with this now. So of course, okay, one more question. Hash hash a, is this same as, or maybe this will make more sense. Hash hash s, is this same as s? No, s has already gone in the list of individual characters that we saw from 1000 to 1997. This is different. So you of course have all the letters, the characters of English, but you also have their hashed versions, okay. So hash hash s you will find here, hash hash a is somewhere there, hash hash e, I, and so on. Of course these are vowels, so they are appearing. I mean, I don't know, if you ask me why are these appearing, can we give a thought to it? Why are these vowels appearing first? So hash hash a, hash hash e, I, and then you see ing. I mean, of course we understand why this frequency is high. So fine, but I am not going into that, why these subwords are so frequent. Okay, so from there words appear to be sorted by frequency. Top 18 words are the whole words, and then number 2016 is hash hash s, presumably the most common subword. The last whole word is 29612, necessitated. And he finds these inclusions funny, so fine. The following code prints out all these single. Okay, so now what he is doing in this code is simply just that there is a occurrence of hash hash s for a lot of things. I mean hash hashed versions versus non hash hashed versions. So he comes up with something like, so for example, he mentioned something like that hash hash ly is present in the vocabulary, but ly alone is not there, because ly is, when do we use? Adjectives. Okay? Hardly, highly, okay, and so on. So this ly is the hash hash ly is there, but ly alone is not there. So I think this is, so for example, this is hash hash ly is there, but ly alone is not, and now that's it. So you can So he also, so in this collab he does a lot of things. So he says if you are talking about corpuses, for example, spelling of government, what is it? Government. So this N, but it is not unusual to forget this N, just writing government excluding this N. So he tries whether there are misspellings also there in this vocabulary, because government, it's not that unusual to find. For maybe every 10 occurrences of government, you might have one occurrence of government, okay, but there are no misspellings here. So I don't know what has happened to this guy. Okay, so you have single characters, you have that rupee symbol as well. So this seems to be Korean and Japanese, this seems to be Mandarin. Number of single character tokens with hashes. So number of single character tokens with hashes, you see these guys as well, non-English things too. So BERT is actually super powerful. I mean, you have to go and think about it. Okay, so this one, this is simply plotting the number of tokens. What is there on the x-axis? The token length. So if you see, the highest is for 6 and it looks well distributed. 1 has a huge number because all those single characters, right, they account for this one, and the longest one is 18. So we look at just the tokens which begin with hash hash. Okay. So the number of subwords are 5828 of 30,522. So the numbers with, I mean the tokens with hash hash are 5828. Okay. I mean, nobody is going to ask you this number, but just you should know that this is roughly 20% of the BERT's vocabulary. And okay, so number of subwords now, as you can see, the same plot, but it is for now just the all the tokens with just hash hash. So misspellings, so misspelled in tokenizer, false. So government, for example, government is true, but government is false. So misspellings are not there, they might have deliberately kept out of it, but BERT was trained on what? Book corpus. So the likelihood that there were misspellings is much lesser compared to the internet crawl. Right. So for example, beginning with the right spelling is there, but beginning with wrong spelling is not there. So he tried a couple of them. So can't in tokenizer is false, can't is also false. Okay. Start with mid sub. So this we have talked about. Hash hash ly is present in the vocabulary, but just ly is not. So what he did now was, he downloaded a file that has a lot of names, firstnames.txt, and now he tries to search how many names are there in the BERT vocabulary. It turns out the number of names in the file which he used was roughly 22,000, okay, and there are 3869 matches in BERT vocabulary. So in 30,522, you see 3869 are, at least 3869 are names, because the matching was done for only 22,000 names, maybe this might still, so roughly 8,000 are just names. So BERT vocabulary has names, it has all the characters and so on. So it's a very rich vocabulary. Further research, and now vocabulary includes 881 numbers. You will also see things like years. So vocabulary includes 384 of 421 dates from 1600 to 2021. So I think that is it. So now you know BERT vocabulary. So let me just go. So BERT vocabulary is huge, okay, and I think pretty much that is it for today's class. I don't want to start a new thing. The next class will start with I'm not sure whether I will do T5 first or GPT-2 first. So we'll start with either of these. Okay, chalo, thank you. So subscribe to this channel, Chris McCormick. He has some tutorials available online too. So, but though those are behind paywalls. But whatever is here on his channel, you should go through everything.